How to Get from Good to Great in Mobile Robotics and Mobile Applications, presented by Advanced Motion Controls. My name is Kimberly Leaders, and I'm with Motus Labs, who is the sponsor of this webinar. Advanced Motion Controls is an authorized partner of Motus Labs. We design and manufacture a new line of innovative geared solutions for robotics and motion control. Before we begin, if you have a question, just place it in the Q&A section, not the chat area. We will address all questions at the end. Now I'd like to turn it over to Rene to kick off the presentation. Rene?
Hi, I'm Rene Ymzon. I'm the marketing manager here at Advanced Motion Controls. I've been in motion controls for over 20 years, originally starting as an applications engineer. I want to thank Motus for inviting us. If you aren't familiar with their products, I highly suggest you look them up. The innovation and engineering that went into their M-Drive gears is pretty cool. As a mechanical engineer, it's pretty satisfying just to watch how the gears move. All right, David.
Thanks, Rene. I'm David Gelfuso, and I'm Senior Vice President at Advanced Motion Controls. I started out as a regional manager in 1998, and now, almost 23 years later, I oversee the day-to-day operations of the entire organization. As a mechanical engineer, I've been in the motion control industry for almost 30 years, and I'm very excited about our partnership with Motus Labs and their truly amazing geared solutions. So, all right, let's get started.
Advanced Motion Controls was founded in 1987. The two gentlemen that founded the company are still involved in the business today. And that's important because the core values and the culture that the company started with have continued through today. We've shipped over 3 million servo drives around the world. Our headquarters is in Camarillo, California. We have an 86,000 square foot facility that houses all of our engineering, sales, support, design, and our manufacturing. One of the things that sets us apart are our people and our support capabilities. We have over 140 people here in the headquarters, over which 40% are degreed engineers. In addition to the support that you can get directly from the product and support group, we also make our development engineers available to our customers whenever it's needed to provide that extra level of support. Outside of our internal support, we have over 40 channel partners around the world with over 300 associates, and about 150 of those have been to the factory for training. And so we have factory trained support all around the world. One of the keys to our success is the flexibility that we have in manufacturing, because we have all of that manufacturing at our headquarters in California. We do 100% complete testing. Our flexibility allows us to prioritize and schedule to meet our customer needs. We routinely ship over 98% to our promise date and over 95% to the date our customer requests at the time of order. It also gives us great control over quality and reliability. Our average return rate is less than 0.35%.
All right, thanks, David. Today we're talking about servo drives for mobile robots and cobots. So I'm going to start with a quick introduction. Mobile robots can be used pretty much anywhere, but we're seeing exceptional growth in automated warehouses where AGVs are used to fulfill online orders, in hospitals, for example, pharmaceuticals. This is where a robot stores and transports medication to a patient's room in the hospital. Also in hospitals as service bots where they do laundry delivery, so delivering fresh linens to the rooms, or taking dirty linens to be laundered. Or even at grocery stores, in airports for automated floor cleaners. Also in grocery stores and big box stores, mobile robots are used for tracking inventory. Cobots or collaborative robots take the shape of an arm and are usually mounted to a fixed location, but they can also be mounted to a mobile platform, which allows them to move and work where needed. Cobots work in close proximity to people and other robots. They're designed to be versatile so they can handle a multitude of repetitive tasks like moving, sorting, packing, and assembly. In both mobile robot and cobot applications, for every axis of motion, there needs to be a motor to drive it. And to drive each motor with precision, there needs to be a servo drive to supply the power and motion control. This means for every traction wheel on an AGV, or every degree of freedom on a robot arm, there needs to be a servo drive. But regardless of the different applications and different jobs for each axis, when it comes to the servo drives that power them, mobile robots and cobot applications have a lot of requirements in common. So even if the application looks different on the surface, the requirements for the servo drives are actually similar. So what are the requirements for cobots and mobile robots, and how does AMC fit in? First of all, we have 220 standard off-the-shelf servo drives to choose from. Within this group are a lot of great choices. So I'm going to break this down into the attributes that are important for cobots and robots. With regard to voltage, compared to traditional factory applications, mobile robots and cobots operate with a relatively low DC supply voltage, typically in the range of 10 to 100 volts DC. This is mostly due to the availability of batteries and safety, although higher voltage systems also exist, for example with industrial robots and agricultural robots. In the low voltage category, our standard products operate over a wide range. For example, 10 to 55 volts, 20 to 80 volts, and 40 to 175 volts DC are typical operating voltage ranges for our products. The benefit of wide ranges is especially important with battery applications because the difference between a fully charged battery at the beginning of a shift versus a drain battery at the end can be pretty big. And regardless of what the input voltage is, the servo drive performance should remain the same throughout the range, meaning the responsiveness needs to be the same as well as the torque output and tuning, although admittedly the top speed may suffer when the voltage is low. Almost everyone wants more torque, which really means they need more current. Anywhere from 5 amps to 100 amps is a typical requirement and can easily be satisfied with our standard product offering. Even higher currents are available with some of our products like our vehicle mount drives. High current output is needed for axes like traction wheels on an AGV or the base joints on a robot arm. Efficiency plays a critical role when batteries are the source of power. The higher the efficiency, the less wasted energy. This means robots can run longer because their batteries last longer. At AMC, all of our products use some form of PWM switching, which makes them inherently efficient. The point is, the power devices, either the FETs or IGBTs, turn all the way on or all the way off, with very little time in the linear region where energy is wasted. The result is efficiency, usually between 95 and 99%, depending on the model. More efficiency means longer battery life. Also, being more efficient, this goes hand in hand with being more thermally efficient, which means there's less heat generated by the servo drive. This is extremely important when space is limited, like with cobots and mobile robots, because when servo drives and other electronics are packed into tight spaces, the heat tends to build up. Thermally efficient electronics are much easier to work with because they run cooler. Another consideration for efficiency is we have 4-quadrant operation, including for single-phase and 3-phase servos, as well as trapezoidal and sinusoidal commutation. 4-quadrant means the servo can push current in both the forward and reverse direction, as well as regen in both directions. So what's regen or regeneration? This is when the power flows from the motor back to the supply during braking. In the past, this was often considered a nuisance, since it would cause overvoltage issues and make machines shut off. But now with battery applications, regeneration is now a desired feature. It's actually an integral part of maintaining the highest amount of efficiency and recovering as much spent energy as possible. In the past, excess regeneration energy will be burned off in a resistor. Now it's used to recharge the battery. Our products are not only known for their high power, but their high power density. In simple terms, high power density means increasing the amount of power per volume. If you provide the same amount of power but in a smaller package, then you've increased the power density. For example, these two servo drives can output about the same amount of power, but this one has much higher power density since it is so much smaller. The advantage of high power density is it makes it easier to fit more power into a smaller space, an extremely important consideration in AGVs and robotic arms. Also, with the smaller physical size comes reduced weight. Every gram of mass saved increases the payload capacity. The reduction in dead weight also helps with overall system efficiency because there's less weight to move around, accelerate, or lift. Networked servo drives are definitely the way to go with cobots because they greatly simplify wiring. A compact drive on a network can be mounted right next to the motor in a cobot arm. All the feedback signals can then be processed in the drive along with any I/O signals. The servo drive can then make the signals available on the network for the controller to access. This eliminates most of the wiring that would otherwise have to feed down the arm. Multiplied by each axis of motion in the arm, this means 50, 75, or more wires can be eliminated. Safety is a top concern because AGVs and cobots work near and around people. Safe torque off, or STO, cuts all power to the motor. This safety feature is necessary when someone is servicing a robot because there needs to be absolute certainty that a motor can't suddenly turn on and accelerate, causing injuries. People might equate this to an inhibit function, but this would only be half right. The difference between an inhibit and safe torque off is the inhibit is done solely through the servo drive's logic. This means a logic glitch or poor grounding could allow the motor to start up again. With safe torque off, the drive's logic is taken out of the equation. With STO, there's a physical disconnect on a hardware level between the drive's power devices and the motor phase terminals, making it virtually impossible for the motor to accidentally start up. To start the motor again, STO must be disabled manually before the drive can be re-enabled. Form factors. PCB mount is our most integrated form factor. With this style, you design your PCB to accept the servo drive directly on the board. To get the full advantage of this form factor, you would design the PCB board in such a way as to be laid out in the shape that you need, and if necessary, include multiple axes on one board. Further advantages can be achieved by designing easy connection to the motor and feedback cables, as well as tying together the network comms, especially if there are multiple axes. Traces and connectivity for I/O should also be included. Think of the PCB mount form factor as an easy way to do your own custom, but you don't need to design the servo drives. You just need to integrate them. The advantage is the tightest integration with extremely reliable connectivity since cables are replaced with traces. Disadvantage, it's an open design, so not as protected, and you need to really plan out the layout and connectivity since it's more of a commitment to spin a dedicated board. Machine embedded is similar to the PCB mount style, but with an interface board attached. This allows for more traditional connections like cables with connectors. Advantage, it's more standalone. Disadvantage, it's still an open design. Panel mount, this is the traditional servo drive in a rectangular case. They're larger than the embedded style of drives, but they have bigger connectors and sturdier mounting options. Advantage, they're well protected with a metal or plastic cover, larger connectors with easier access. Disadvantage, these may be harder to place due to their size. They're also heavier. Vehicle mount, designed with electric vehicle requirements in mind, although they're still servo drives, so there's no sacrifice in performance. They use automotive style connectors for signals and large lugs for power. So the advantage, it's the most protected design. It's a heavy duty build. Disadvantage, it may be too bulky. Let's focus on FlexPro. FlexPro is our premier line of servo drives. They're a showcase of our latest technologies and capabilities and are designed for high power and small size. With our impact architecture, we've achieved incredibly high power densities while still maintaining our reputation for reliability and versatility. FlexPro drives are designed to operate within a network, but like previous digital drives, they can also operate standalone with control via stored indexes and sequences using I/O. They're capable of running brushed, brushless, stepper, rotary, and linear motors. They range in power from as low as 5 amps continuous up to 50 amps continuous and 100 amps peak. For voltage, they work with as low as 10 volts DC up to 90 volts DC, with options up to 200 volts DC in the near future. We offer two sizes, the micro and the mini. The micro size has a footprint of 38 millimeters by 25 millimeters, which means 4 of these can fit onto a business card. The mini size has a footprint of 43 millimeters by 38 millimeters, which means 2 of these can fit on a business card with room to spare. Form factors. FlexPro drives come in 3 form factors. PCB mount for fully embedded and integrated installations. These are great for multi-axis applications we can mix and match as many FlexPro drives as you need onto a single PCB. Machine embedded, these drives are the halfway point between PCB mount and panel mount. They have an open, caseless design, but they use standard connectors and lugs for connectivity. Panel mount. This is the traditional rectangular case that most people associate with servo drives. And one more form factor worth mentioning is the development board. Since the FlexPro models are so small, we also have available an embedded style FlexPro mounted to a larger PCB with full-size connectors for main power, network, motor power, and feedback. The FlexPro family has options for EtherCAT, CAN-open, and Ethernet IP, giving full control and access to drive stats and I/O over the network. For safety, all FlexPro drives include STO functionality. Feedback. FlexPro drives have numerous feedback options including absolute encoder, BIS-C, NDAT, incremental encoder, Hall sensors, and more to come. Extended environment. FlexPro has a complete subset of models designed to operate in extended environments. They've been ruggedized to work in different applications like high temperatures or high vibration, both of which are common with cobots and mobile robots. They have an extended temperature range of -40 to 95 degrees Celsius. They're protected against 95% non-condensing humidity and pollution degree 2, and they're tested to withstand vibration up to 5 minutes of 25 Gs RMS in 3 axes of vibration.
Thanks, Rene. That was great. In addition to all these standard products, and you can go to our website and you can see them all online, that only represents about 1/3 of our revenue. Another third of our revenue are modified versions of those standards. So we can tweak small things like resistors, capacitors, maybe even special firmware, things like that. But then the final third part of our revenue is custom solutions, where we are taking our core building block, right, a standard product, the standard circuits that go into that product, and customizing it for shape or power, a voltage current, inputs and outputs, special connectors, things like that, to give the OEM customer exactly what they want. One of the keys in getting good to great in mobile robotics is being able to have a solution that's optimized for the application. Every application is different, every customer's needs are different, and the ability to customize on the product level, and sometimes even on the commercial level, is very important. And the way that advanced motion controls is structured lends itself very well to being able to be customized and optimized. And we like to think of ourselves as an extension of our customer's engineering team. So we have a very close collaboration between our applications department, our engineering group, as well as the customers. We build all of our prototypes on the same equipment and the same process that we do for our standard products. So we have that proven recipe already built in. And our experience of over 30 years, coupled with our in-house facilities and capabilities, produce reliable custom solutions and much faster than the other suppliers in the market. Many of our competitors don't even offer custom solutions. So an example of one of our custom applications is a floor cleaning robot. And the customer had started using one of our standard embedded style drives plugged into their own mounting card and an IP65 enclosure. And they recognized that their forte was building robots and the controls of robots, not necessarily the drive itself. And so we worked together and collaborated on a turnkey solution where we provided a fully enclosed IP65 totally sealed solution. So the building block was still that standard drive. We created a mounting card that had on exactly the features that they needed. It was the same size as their own design, so the fit was the same. We mimicked the function, so there were special relays, temperature control, safety mechanisms that they had designed on their mounting card, and we put that onto our design. Added a couple waterproof connectors and put that into a plastic housing and completely filled the cavity with potting compound to make a 100% sealed solution. This gave them the ease of buying one part, taking it right from their stock, mounting it right to the robot in the same fashion that they had mounted their own design with the same cables, because we had used the connectors they used, lowered their costs, increased their quality, and we made it simpler for their supply chain because now they were buying just one part as opposed to all the different parts to put together that assembly. Another one of our custom examples is a customer making an articulated robot that goes on top of a mobile robot. For the articulated part of the robot, it was very important to keep the size as compact as possible. And to do that, they wanted to have the drive fit right in each joint of the robot. So it had to be small, it had to be circular, and it had to be donut style with a hole in the middle for wires to go up through the drive to get to the next joint and the joint after that. This was an EtherCAT solution, so the communication between the host and our drive is EtherCAT. We worked together with the customer to determine the exact size, the exact mounting holes, and what was very important was efficiency, because there's not a lot of extra space to be able to mount the power devices, which are the heat generating part of the design, to the metal housing. So we had to be very efficient to allow for natural cooling. And the other issue that was very important to them was the connectivity. They had very specific requirements when it came to connectorization, because the connectors had to be small, right, to keep the whole design small, but they also had to be very rugged and reliable, because this moving 6-axis or 6 degree of freedom robot is moving a lot. And so there's going to be stress on the wires as it's moving around. So the ability to have robust connectors was very important. In addition to that, we added some features just for them: a special brake function, a special torque sensor function, in addition to sensing the torque of the motor, and a couple other features that will set them apart from their competition. And it was a really good example of how the two engineering teams working together as one could produce something better than either they or us could do by ourselves. Another application was for a different floor scrubbing and floor cleaning robot. And the special need in this application was dual axis. So they wanted to have 2 axes on one drive, and all of the filtering necessary for them to meet their emissions requirements. A lot of times customers will handle emissions external to the servo drive itself, but in this case they wanted a turnkey solution where they did not have to add any additional equipment or accessories to the drive in order to get it to pass the testing that they required. So we took 2 standard embedded style drives that were slightly modified for voltage and current and installed those on a custom printed circuit board, acting as their mounting card, with high power, high current lugs for the input power and the output power to the motor, as well as the signal connectors of their choosing. So they had exactly what they wanted, and that helped them with their cabling. And on the opposite side of the mounting card, all of the inductors and filters necessary to keep the EMC and the emissions both conducted and emitted to a level that they required. Again, this helped them ease their supply chain by being able to buy one part as opposed to maybe 2, 3, or 4 different pieces to put together themselves. They could buy one part and stock it kept their costs down, made it much simpler to stock the product as well as manufacture the product. One of our customers was making a mobile robot that is being used in a factory where Ethernet IP is the network of choice, the communication protocol of choice. And so we had EtherCAT products, which were very similar but different. And the EtherCAT product that we had was an embedded style amplifier. So they liked the amplifier, they liked what it could do in terms of capability and performance, but they needed a different network, and they needed it to be in a housing with connectors so they could mount it in a panel. So this is an example where we started with a building block, and it was actually our FlexPro building block, and we were able to replace the EtherCAT portion of the drive with an Ethernet IP interface. So the power and the controls stayed the same, only the network and communication option was added. And then we took this drive and put it into a custom mounting card. And the custom mounting card had a power supply that took the bus voltage from the battery of the mobile robot and turned it into the voltage necessary to run the logic of the amplifier. We added the connectors that they wanted for the power, the motor. They wanted D-sub connectors for the inputs and outputs. They told us which USB connector they would like to have, the types of switches to be able to set the addresses for each axis. And we even included fans to provide active cooling, and they blow over the drive when the drive gets to a certain temperature in order to keep all of the electronics in the zone that we want them to be to operate properly.
Okay, we're ready to answer some questions. Remember, you can submit questions by clicking on the Q&A button at the bottom. So, all right, so our first question to our esteemed panel: how did you prevent signal interference on the boards, signaling circuit from the passing wires? So I believe I saw that question pop up when we were doing the donut-shaped board. So maybe is when the wires pass through there. So I'll leave it to you, either David or Keith, to answer that.
I can I can take that. It's a good question. Electrical interference, both conducted and emitted, is always a concern. And there's three main ways that we take care of that. The first is the circuit design on our board to limit the amount of noise that we put out from the switching power devices. We have techniques that's part of our IP that reduces the amount of noise emitted. We also have circuits that we put on our boards to decrease the susceptibility of interference from outside sources affecting the drive. So those are circuit designs that we use to mitigate those problems. That's number one. Number two can be active components or passive components that we add to reduce filtering. Those can sometimes be internal to the drive. An example of that was on the dual board integrated on the back side of that board. You saw a lot of what look like large cubes, and those are inductors that help knock down noise. Sometimes they can be on the board. Sometimes they can be on the wires, actually attached external to the board. And then thirdly, proper shielding, which is a requirement that we put onto the customer. The customer has to make sure that their wiring is shielded properly and grounded properly. And so those three things together help mitigate signal interference, both from the high power and low power side of things.
All right. Next question. Do you do vibration testing?
I'll take that one also. Another good question. These are all good questions as I see them pop up. All of our standard products have a standard vibration rating, and those have been tested. Our extreme environment products actually are tested to an even higher level of shock and vibration. And many times when we're doing custom solutions, the customers will have very specific vibration or shock requirements. And we have several labs locally here in Southern California that we use to do specific testing. So that's a long answer to yes, we do vibration testing. And having done this for 30 years and having a return rate of less than 0.35% is evidence that not only the vibration testing, but all the other validation that we do allows us to provide very reliable and high quality product.
Right. Do you have click and move applications in the AGV AMR industry?
I guess I'll take that one. So thanks for the question again. I currently don't know of any specific applications that we're using to service or using click and move to service the application in the AGV market. We've talked to a number of customers and certainly have some capabilities on that front. But today I don't know of any specific applications. But the flexibility of click and move certainly allows us to take on those kinds of applications. So if you've got some requirements, let's talk about them, and I think we can probably help you out.
All right, and that was Keith Bosecker, our sales regional sales manager. All right. So with the smaller FlexPro drives, is there any performance loss in the servo loops or responsiveness when compared with larger traditional servo drives?
Give that to me again, Rene.
Sure. With the smaller FlexPro drives, is there any performance loss in the servo loops or responsiveness when compared with larger traditional drives?
No, in
Keith,
fact,
go ahead.
Okay. No, in fact, the FlexPro drives are every bit as good in terms of performance as the other drives that we've been building for years and years. In some cases, maybe slightly better. Efficiencies, because of the newer devices and newer designs, have actually improved. So FlexPro has been a great addition to our product line, and certainly getting a lot of interest. And I know, Rene, you talked about it during the webinar here about the power density piece of it. It really is shines greatly in that front too.
All right, thanks, Keith. So how is heat managed when a servo drive is mounted inside a robot arm or attached to a motor?
I can take that one. So typically when we're embedding a drive into a tight space like that, we work very closely with the customer. So we act as an extension of their engineering team. And so together we come up with not only tight electrical specifications, but also mechanical. And so we will share the thermal dissipation requirements between ourselves and the customer. So on lower power applications, we can get away with no additional heat sinking and no additional active cooling. As the power increases, or maybe the ambient temperature increases, when it is time to provide some sort of cooling, more than just the drive itself, what we can do is create an interface. So we can actually use part of the metal that's inside the robot or the robot arm or the end bell of the motor to attach the drive power devices to. And that tightly integrated solution allows us then to pass the power that is dissipated by the switching power devices to the robot itself. And we have a lot of experience and the tools necessary to do thermal modeling. So again, we've done that a lot, and we have a lot of success in coming up with robust and integrated thermal designs.
All right. How long does it take to get a modified or custom solution?
I'll take that one. So modified solutions, which are based on standard drives and modifications that if it's something easy, it could be in a matter of days, right? If we're changing resistors and capacitors out to a couple weeks. If we're doing a full custom design, once we have the requirements document set in stone, and we start the design, put the boards out for purchase, and then build it and test, we're looking at anywhere from 6 to 12 weeks to have a prototype shipped out, and that prototype is going to be pretty representative of the final product. It's rare that we have to go through another spin unless the requirements have changed. So we can usually get a prototype out between 6 and 12 weeks, depending on the complexity.
All right. Can you work with most motor suppliers? I think I'll take my hand at trying to answer this one. I'd say yes. If you go on our website under products, we have a third-party product compatibility section of our website, and we have a list of motors that's pretty long that we have worked with. So they're all confirmed that we have operated with them in the past. And we always like to say we can work with any motor, any application, any feedback, any controller, any industry. So being focused, our products being focused as we make servo drives, we don't make motors, we don't make controllers, well, other than click and move, but we don't make feedback. It kind of keeps us honest, and we have to be compatible with as many different components as possible. All right. How much does a custom servo drive cost compared to a standard product?
I guess I'll take that. So really it comes down to the devil's in the details in these situations. We've actually designed custom solutions that would come out less expensive than the standard purposely to meet the commercial needs. But in a lot of cases, there's actually pieces of the customer system that are added to it, essentially adding cost, but the overall buy cost ends up being cheaper for the customer. So we might take on some more of their electronics design, add it to the PC board, and build it all at once. And so then, the end solution ends up being cheaper than if they were to go out and buy some of the separate components and do that themselves. Additionally, they don't have to manage the product because we give them a fully tested, fully warranted module at that point. And we deal with all the other pieces of that, which would be, end-of-life components or, some of the potential redesign issues that could come along. So we give them a good high-level solution. And in a lot of cases, it comes out when you do kind of a cost comparison, it comes out to be either equal or less than what they're paying for the individual components.
Thanks, Keith. And just a reminder, just press on the Q&A button if you have a question, just submit it, and we'll go ahead and read it out. All right, so the next one, how would I go about designing my own PCBA for a plug-in drive?
I can take that. We obviously showed a bunch of examples where we're doing custom interface cards, but a lot of times our customers want to interface it directly for our plug-in style. And with all of our families of embedded style drives, we provide reference designs in our documentation that allow you to take the core componentry and circuitry that we've used on our standard mounting cards and embed that into your own design. So we make it very easy for the OEM and the customer to do their own interface card.
All right, thanks, David. Have you been part of any applications which wanted to connect the servo drives via a 5G network?
I'll answer that. Not to date. We haven't had any customers request that. However, we do have several customers that are making mobile robots that their control system is wireless, whether it be cellular like 5G or Wi-Fi or Bluetooth or some other style of wireless communication. And so we have seen that done at the host or controller level.
Okay. Do the FlexPro drives have an option for a cover?
I guess I'll take that. So the FlexPro designs are starting out as modules. As Rene talked about during the webinar, they're, for the future, we're anticipating some panel mount style designs that'll leverage the FlexPro capability and the power density. So the expectation is we'll have both panel mount and then also vehicle mount style FlexPro designs coming out in the future at higher power levels too. So we've kind of gotten to a place where we can increase those numbers, and engineering's working on those developments now.
Right. All right, there's no more questions. We'll be sending out this recording later today. You're always welcome to contact us. Just go to our website at a-m-c.com. We have an excellent technical and customer support team, and we can help with sales, product selection, system evaluation, configuration, and troubleshooting. Thanks again to Motus for sponsoring this webinar. You can check out their gear solutions at motus-labs.com. This concludes the webinar. Thanks, everyone, and have a great week.